Hello, welcome to Now Maths Strategy. In this session, we learn about the surds or radicals. First of all, let's understand what surd is. But before we proceed into the video, first of all, I would like to ask to the new visitors to subscribe to my channel and press the bell icon so that you get all the updates regarding our new uploads. So let's get into our lesson. First of all, check what surd is. So we can define surd as a root of a non-perfect square number is a surd, or also we can say that surd is a root of an integer which can't be a whole number, or root of an integer which cannot be expressed in the form p upon q. Okay, so let's try to understand with some examples. Like we say root 4 is 2, root 9 is 3. So these are perfect square numbers. Okay, these are perfect square numbers, and these roots can be expressed as whole number, right? So these are perfect square number. And if we say what is root 2, okay, so what is root 2, what is root 3, what is root 5? So these numbers, okay, root of these numbers cannot be a whole number, okay, and these numbers can't be expressed in the form of p upon q. So these roots of these numbers are the surds. These are surds. Okay, I hope you understood here. Now let's try to understand the order of surd. Okay, so order of a surd, let's try to understand. For example, if I have root of 2, so the order of this here is no number, so this is the order 2. Its order is 2, like root 3, and its order is 2, like cube root of 5. Its order is 3. Order is 3. Okay, for example, if I have m root y, then its order is m. Okay, so the order of sort is now clear, I believe. Now let's go to simplifying or sorts. Simplifying sorts, we have root 18, root 72. We know that 18 is not a perfect square, as well as root 72. 72 is also not a perfect square. So for simplifying these sorts, what we can do, first of all, let's find all the factors of 18. The prime factors of 18 is 2 and 3 only. So root 18 can be written as root under 18 can be written as root under 2 into 3 into 3. Since this is a square root and the pair of numbers will be free from the roots. So here I have a pair of 3. A pair of 3 will be free from this square root. So it's come out, and the 2 is alone. So it will be inside the root. Now root 18 is simplified as 3 root 2. Now let's deal with 72. Let's try to find out all the prime factors of 72. 72 can be written as 2 times 2 times 2 times 3 times 3. So root 72 can be written as root of 2 into 2 into 2 into 3 into 3. Okay, and we know that a pair of numbers will be free from the square. So a pair of 2 is there, so we got 2. A pair of 3 is there, we got 2. So 1, 2, it is alone. So it remains inside the root. Now 2, 3 is 6. Root 2. This is the simplified form of this root 72. Now let's check. It's simplify root 27 plus root 75 minus 8 root 3. Now let's check how to do it. First of all, let's try to find and write 27 as the product of prime factors. So 27 can be written as 3 times 3 times 3, and 75 can be written as 3 times 5 times 5. So we have written 27 and 75 as the product of prime factors. Now let's go on simplifying the surds first. So root 27 we can write as 3 times 3 times 3 plus root 75 can be written as 3 times 5 minus 8 root 3. Okay, so here we see that this is a square root, so a pair of 2 will be free from the square root. So here I have this pair, hence it will be free, and one of the 3 is alone here, it will be inside the root. Plus from here we can see that 5 is making a pair of 2, so the 5 will be free from this square root, and this 3 is alone, so it will remain inside the root, minus 8 root 3. Now we can see inside the root we have 3, 3 and 3. These are like sorts. First of all, let's add these like sorts. So here I have 3 root 3 and here I have 5 root 3. So 3 plus 5 is 8 root 3 minus, again I have 8 root 3. So 8 minus 8 is 0. This is my answer. Now let's take one more and the last question for this session. Now we have root 45 plus root 245 minus root 500 plus root under 625. Let's try to write all these numbers as the product of prime factors inside the roots. So root 45 can be written as root under 3 times 5 and plus root under 245 can be written as 7 times 5 and root 500 can be written as, but before we have minus here, minus root under 500 can be written as root under 2 times 5 times 5 times 5 plus root under 625 can be written as root under 5 times 5 times 5 times 5. Now let's check the numbers that are making a pair will be free from this root. Now let's try to find out. From the first, we got that 2 is making a pair, so this 3 is making a pair, then a pair of 3, that means this 3 will be free from the square root, so I got 3 root 5, and here 7 is making a pair, so 7 will be free from the root, hence I get 7 root 5, and in the third, I can see that 2 is making a pair as well as this 5 is making a pair, so 2 times 5 will be free from this square root, and this 5 is still inside the square root. And in the last one I have that I can see that this 5 is making a pair and this 5 is making a pair, so 5 times 5 will be free from this square root. And now I can see that here I have root 5, here root 5, and here root 5. These all are the like terms. So I can add them. 3 plus 7, I have 10 root 5 minus 2 times 5 is 10 root 5 plus 5 times 5 is 25 and 10 minus 10 is 0 plus I have 25 and finally I have 25 as answer. Okay, dear friends, I believe you might have understood the basic concepts on the surds and you might have understood how to simplify the surds easily. I would like to thank you for watching the video till the end.